The objective of this lesson is to calculate the surface area of three-dimensional figures using a net. In previous lessons, students have learned area is additive. They have decomposed and recomposed figures in order to find the area of different shapes. Today, students will extend their knowledge of area to finding the surface area of figures. A carpenter is building a closed wooden box. She wants the box to have a rectangular base with a length of 13 inches, a width of 7 inches, and a height of 9 inches. Draw a model of the pieces she will need to cut. Label each piece of the model as top, bottom, front, back, left, and right. Let's start opening the box and laying it flat. This is called the net of the rectangular prism. The two smaller rectangles on the sides are the left and right sides to the box. The top piece is the front of the box, followed by the bottom of the box, then the back of the box, and finally the top of the box. The next part to the question asks, how many square inches of wood were used to construct the box? In order to calculate how many square inches of wood is needed to make the box, the surface area must be found. Surface area is the outer measure of three-dimensional shapes. Let's begin by writing down the dimensions for each of the faces of the box. The front will have a dimension of 9 by 13. In order to find the area of this front piece, each individual square can be counted, or the formula of length times width can be used. Counting each square is a correct way to calculate, but using the formula for the area is much more efficient. The area for the front piece is 9 times 13 equals 117 square inches. The next piece is the bottom. The dimensions of the bottom piece are 7 inches by 13 inches. The area equals 7 times 13, which equals 91 square inches. The next face is the back of the box. The front and back are congruent pieces and will therefore have the same surface area. The back has dimensions of 9 inches by 13 inches, which equals 117 square inches. The next face is the top, and the top and bottom faces are congruent. The bottom face has a surface area of 91 square inches. Therefore, the top also has a surface area of 91 square inches. The left side has dimensions of 7 inches by 9 inches, which equals 63 square inches. The right side will have the same surface area, 63 square inches. Next, we will add up all the surface areas of each piece to find the total surface area of the box. 117 plus 91 plus 117 plus 91 plus 63 plus 63 equals 542 square inches. The total amount of wood needed will be 542 square inches. There are multiple ways to find the total surface area. This was just one way. Students should focus on reasoning about the faces, the area of each face, and then adding the area of each face together to find the total surface area. The objective for this lesson was to calculate the surface area of three-dimensional figures using a net. We met this objective by solving a real-world problem where the total amount of wood needed to create a box was found by finding the surface area of each of the faces of a rectangular prism.